Good evening, viewers. This is Kasturi Day. Today, I'll be continuing with the question answers of the periodic table, the remaining question answers. Okay, so before that, I will request you to please to subscribe my channel if you have not subscribed yet, or if you are a new viewer. Okay, and if you are liking the videos, press the like button, share with your friends so that they can also be benefited from these videos. And also do meditate before you start your day. Okay, so let us concentrate for just 1 minute on meditation. For meditation, let us concentrate on a point of light. Think that light is falling on you and you are enlightened. The whole body of yours is enlightened. You are feeling very energetic, enthusiastic, very happy, and doing your job, giving and physically, and you will get I want to tell you this, that you will get all the links of this chapter in the description box. Even the playlist links are also there, and also the link the of my new channel, which is a Bengali channel, a spiritual channel. And if you are interested in that, you can also refer to that. So that link is located. So let us start with. So let us start with the discussion. That is, first question today is arrange the following elements of group 1 in increasing order of reactivity. Elements of group 17, decreasing order of reactivity, helium, sodium, and magnesium. Okay, order of melting point. Okay. Then chlorine, sodium, and magnesium. Magnesium increasing, reducing character. Okay, so let us see the answer. First question is elements of group 1. We know lithium, sodium, potassium, rubidium, cesium, or are all these elements in the group 1. So if we arrange them in the increasing order of reactivity, as we go down the group, we will see their reactivity order increases. So it will be arranged in this way, that in lithium, cesium will be more reactive than rubidium, rubidium will be more reactive than potassium will be more reactive than sodium, and sodium will be more reactive than lithium. Okay? Because as we go down the group, their tendency to lose electrons, that increases. As the size of the atom increases, as we go down the group from lithium to cesium, the size of the atom increases. Therefore, the attraction of the nucleus into, the attraction of the valence electron towards the nucleus, that decreases. And that's why the electron, the valence electron can easily be lost by the atom. So therefore, they're combining their reactivity, that increases because that combines with that will lose the electron, and that will combine. That will get the octet stability. That means the atom will get the stability, stable electronic configuration. Okay. So by doing so, their reactivity increases. Okay? So as we go down the group, their reactivity increases. Then if we, for group number 17, the decreasing order of reactivity. In this group, what happens? As we go down the group, they will gain electrons. We know that they are these halogen group, that is group number 17. They are one electron deficient to form the octet, to form the stable electronic configuration. Chlorine, fluorine, bromine, and iodine, they have 7 electrons in their outermost shell. So they want 1 electron to form the octet. So when we go down the group, their atomic size increases. And as their atomic size increases, then what happens? Their acceptance of electrons, that decreases. Gaining of electron tendency, that decreases. Okay, and therefore their reactivity decreases as we go down the group. Okay, so fluorine will be more reactive than fluorine. Fluorine is more reactive than bromine, and bromine is more reactive than iodine, because these elements are present in the halogen group or group number 17. Okay. Then we come to the third question, that is helium, sodium, and magnesium. They have the increasing order of melting point. Okay, as we know, helium is the noble gas, and magnesium's melting point is higher than sodium due to the stronger metallic bonding. Okay, so the arrangement will be like this. Helium will have less melting point sodium than sodium. Sodium will have less melting point than magnesium. So magnesium will have the highest melting point in this arrangement of the elements. Okay. So why? Because helium is a noble gas, okay, and its melting point is very low, okay, and this sodium will have less melting point than magnesium, and magnesium will have more melting point than sodium because of the strong metallic bonding. Okay, and helium is a gas; its melting point is low. It's a noble gas. Okay, so its melting point is low. Okay, then, and these two are metals. Magnesium is a strong metallic bonding than sodium. That's why magnesium's melting point is more than sodium. Then I think you have understood what I want to say. Okay. Then chlorine, sodium, and magnesium, they are arranged in increasing, reducing character. Okay. Now, as sodium is an alkali metal, they will lose electron very readily. So it loses its electron readily. So it's a strong reducing agent. Then magnesium is also an alkaline earth metal. It also loses electron readily, but not as readily as sodium. Okay, that's why its reducing character is little less than sodium. And chlorine is a halogen which accepts electron to attain the stability. So it's a strong oxidizing. So its reducing character is much less. It's an oxidizing agent. Okay, so chlorine, then comes magnesium, then comes sodium. So sodium is the strong reducing. Okay. Next is name an element of group number 18 which can form the compound xenon. Okay, xenon is an element of group number 18, that is noble gases, which form the highly electronegative element with fluorine and oxygen, forming XF4 and XCF4 and XCO3. Okay. Now state the nature of the compounds formed when groups 17 elements combine with metals and non-metals. Why group number 17 elements are highly reactive? What is the name given to the group number 17 elements? Why are they so called? Comment on the reactivity, color, and physical state of group number 17 elements. So first question. First is, state the nature of the compounds which are formed when group number 17 elements were combined with metals and non-metals. So group number 17 elements, when combined with metals, they form metal halides. Okay. And for non-metals, they form like hydrogen. If they form with group number 17, if they form If they combine with hydrogen, then it forms hydrogen halide, okay, which is acidic in nature. And the first, that is with metals, they form metal halides, okay. Then what is the name given to the group number 17 and why they are so called? They are named as halogens. Why? Because sorry, why group number 17 are highly reactive? They are highly reactive due to their closeness to the stable configuration. Okay, because they have 7 electrons in the outermost shell, that is, they are very close to the stable electronic configuration. That is, they only accept only one electron to form the stable electronic configuration. That's why they are very reactive elements. Okay, they are highly reactive known metals. Okay, then why they are? What is the name given to them? They are given to this group, that is halogen. And why it is called? Because the name has come from a Greek word, that is halo. Halo means sea salt, and gen means producing or forming. So that means what? Sea salt former. Okay, it consists of chlorine, bromine, iodine. These are sea salts, forming sea salts, which are this. That's why they are called halogens. Okay. Then comment on the reactivity, color, and physical state of the group 17 elements. Okay. So the color. Okay, first we come to the reactivity. They are highly reactive non-metals, I told you. Their reactivity decreases down the group. I told you, no? In the previous question also I discussed that chlorine, bromine, then iodine, that comes in this way, and the reactivity goes down the group. I mean, decreases down the group. Okay, that why? Because their atomic size increases and their acceptance of electrons from the other element that decreases, and that's why their reactivity decreases. Now the color, fluorine gives a pale yellow color. Chlorine has a greenish yellow. Okay, bromine is reddish brown liquid, and iodine is violet solid. Okay, so fluorine is a gas, bromine is a liquid, and iodine is a solid. Okay, but fluorine's color is green, pale yellow, fluorine is greenish yellow, bromine is reddish brown, and iodine is violet. Okay. Then astenine is also there, but it's a very rare element. That's why we generally don't discuss it. Okay. Now, next question is name the alkali metals. How many electrons do they have in the outermost orbit? Take any one alkali metal and write its reaction with oxygen, water, and acid. Name the method by which alkali metals can be extracted. What is the color of the flame of sodium and potassium? So, name the alkali metals. That is lithium, sodium, potassium, rubidium, cesium, and francium. These are all alkali metals. All of these are alkali metals. They have only one electron in their outermost orbit. Okay. Now let us take sodium. Yeah, the question says that take any one alkali metal and write its reaction with oxygen, water, and acid. So we take here sodium. With oxygen, sodium forms sodium oxide. Okay, so 4Na plus O2 will give us 2Na2O. The reaction with water, it forms sodium hydroxide and hydrogen is formed. So sodium reacts with water to form sodium hydroxide and hydrogen. It's an alkali, it's strong alkali. Then reaction with acid with sodium reacts with acid to form sodium chloride and hydrogen is liberated. Okay. Then how are they extracted? They are extracted from their alkali salt by the process of electrolysis. Okay. Now, the color of the flame of sodium is a strong, persistent orange or yellow orange. Strong, persistent orange, or you can say yellow orange. And that of potassium is lilac, light purple. Now, name the first 3 alkaline earth metals. Write their reactions with dilute hydrochloric acid. And how do the alkalis how do the alkaline earth metals occur in nature, and write the electronic configuration of the first two alkaline earth metals. So, alkaline earth metals, the first three of them are beryllium, magnesium, and calcium. Okay. Now, the reactions with hydrochloric acid, beryllium with HCl forms PeCl2 and hydrogen is liberated. Magnesium with hydrochloric acid forms MgCl2 and hydrogen is liberated. Calcium again with hydrochloric acid forms calcium chloride, CaCl2 and hydrogen is liberated. Then, how do alkaline earth metals occur in nature? They occur in the combined state because they are very reactive. Okay. And beryllium, the electronic configuration, it has 4 atomic number. Therefore, it forms 1s2 and 2s2. That's K shell, it has 2 electrons, and L shell, it has 2 electrons. Magnesium is 12. So 1s2, 2s2, 2s6, and 3s2. That means in the L shell, it has 8, K has 2, L has 8, and M has 2 electrons. Okay. Next question is, helium is an unreactive gas and neon is a gas of extremely low reactivity. What, if anything, do their atoms have in common? What common factor is there between helium and neon? Though helium is unreactive and neon is low reactive, extremely low reactive. Helium and neon, they have completely filled valence shells. Helium has 2 electrons in the outermost shell, that's complete nucleated form, and neon has 8 electrons in the outermost shell, their octet is formed. So both of them are in the same group, that is inert gas group, that is group number 18. That's why these two factors are common. Then in which part of the group would you separately expect the elements to have the greatest metallic character and the largest atomic size? Now, in group 1, we see that if they donate 1 electron to attain octet configuration and stability. Okay. So, their metallic character is more. That is, in the first part of the periodic table. But when we go down the group 1 is okay, that is in the first part of the periodic table, that is in the left side of the periodic table, their metallic character is more. Even in the left part also, if we go down the group, that is the bottommost element of the group, that gets them, that has the greatest metallic character due to the largest atomic size, because they have large atomic size, the atomic size increases, their metallic character down the group, that is in the bottom part of the periodic table, that has more metallic nature, metallic character. Okay, this reduces the largest atomic size, that reduces the effective nuclear charge on the valence electrons. That is, in pulling, that is the attraction of the nucleus attraction of the valence electrons towards the nucleus, that decreases. Okay, that's why the metallic character increases as we go down the group. Okay, so you can say that is on the left hand side and on the towards the bottom, that has more metallic character. Okay, then largest atomic size, the bottommost element of the group will have the largest atomic size. As we move down the group, the atomic size increases, the shells increases rather, and this increases the atomic. Now, what happens to the number of valence electrons in atoms of elements as we go down the group of the periodic table? On moving down the group, there is no change in the number of valence electrons, as the valency for all the elements present in the same group are the same. We know that the valency of the one group, that is same. Therefore, the valence electrons does not differ. That remains the same. What is the main characteristics of the last element of the periodic table? What is the general name of the such element? So the last group of the periodic table, it has completely filled outer shell, valence shell, that is completely filled. Outermost shell is completely filled, whether it is 2, it is duplicate, or 8. that is octet. That is totally clear. Okay, and these are known as inert gases. Then sodium and aluminium have atomic numbers for 11 and 13 respectively. They're separated by one element in the periodic table and have valencies 1 and 3 respectively. Chlorine and potassium are also separated by one element in the periodic table, their atomic number being 17 and 19 respectively. Yet both have valency number 1. Okay, explain. So electronic configuration of sodium, we know it's 2, 8, and 1. And electronic configuration of aluminium is 2, 8, and 3. So sodium will lose one electron. Okay, it has one valence electron, and aluminium has 3 valence electrons. So valency of sodium is 1, and aluminium has 3. Okay, so then for electronic configuration of chlorine, it has 2, 8, and 7, and electronic configuration of potassium is 2, 8, 8, and 1. So chlorine, it will accept one electron. It has to accept one electron to complete its octet, to complete a stable electronic configuration. Here is noble gas. So for that, it requires only one electron. So its valency is 1. Okay, on the other hand, potassium will lose one electron to form the octet. Therefore, its valency also is 1. Okay. Now, name an element whose properties were predicted on the basis of its position in the Mendeleev's periodic table. Name 2 elements whose atomic weights were predicted on the basis of their position in the Mendeleev's periodic table. How many elements were known at the time of Mendeleev's classification of elements? Name the group of elements missing from Mendeleev's original periodic table. Predict the formula of hydrides of carbon and silicon using Mendeleev's periodic table. Predict the formula of oxides of potassium, aluminium, and barium. Name the basis of classification of elements by Mendeleev. State the reasons for the contribution of Mendeleev to the concept of periodic table, which laid the foundation for the Mendeleev for the modern periodic table. So first question, name an element whose properties were predicted on the basis of its position in Mendeleev's periodic table. It may be gallium, germanium, or scandium. Okay, so gallium, which was known as Ica aluminium, germanium or Ica silicon, and scandium as Ica. So any of the two can be written because it has mentioned only one. So name an element is there. Okay. Next question is name 2 elements whose atomic weights were corrected on the basis of their position on the Mendeleev's table. Gold and platinum. Okay. Then how many elements were known at the time of Mendeleev's classification of elements? 63 elements only. Others were not known. Then name the group of elements missing from Mendeleev's original periodic table. Its group as C is in, sorry. Okay, the group of elements which were missing, that those were known as actinides and alkanides. Those were missing. Okay, then that was not discovered at that time. Even the inert gases were not discovered at that time. Okay, noble gases, that is the inert gases, they were not discovered at that time. That group of elements were missing. Okay, not the lanthanides and alkanides, but noble gases, they were missing. Then predict the formula of the hydrides of carbon and silicon using Mendeleev's periodic table. So hydrides for carbon is group number 4. So its valency is 4. The hydride will be CH4, which is known as methane. And silicon is group number 4. That's also group number 4. Therefore, the hydride will be silicon hydride, which is known as silane. Okay. Then for potassium, next question, for the formula of oxides of potassium, aluminium, and barium, potassium lies in group number 1. Oxide will be K2O. So valency is 1. So the oxide will be, and oxygen as oxide, oxygen has valency 2. Therefore, K2O will be the formula. Aluminium is in group number 3, so its valency is 3. Therefore, oxygen has valency 2. Therefore, oxide will be Al2O3. Barium is group number 2, therefore its valency is 2, and oxygen also valency is 2. Therefore, it will be BaO. Okay. And then the basis of classification of elements by Mendeleev is atomic mass and similarity in the chemical properties. Okay. Then state the reasons for the contribution of Mendeleev to the concept of the periodic table, which led to the foundation for the modern periodic table. Okay. So Mendeleev laid the foundation for the modern periodic table by classifying 63 elements in the increasing order of their atomic masses. Okay. He classified 63, at that time 63 elements were known. So 63 elements he classified in the order of increasing order of atomic masses. He arranged them in 8 groups by leaving gaps for the undiscovered elements and predicting their properties. He left certain gaps, okay? 8 groups he arranged. He made separate groups for metals and non-metals. He also created periods in which the elements gradually changes from metallic to non-metallic character. He also in this period, he was also able to show that the elements of the same subgroup had the same valence. These all things, mainly these things are found in the modern periodic table. You can see the gaps have been filled now, but elements are also more elements are being classified, but the modern periodic table has filled those gaps. Okay, the elements which have been discovered now that are filling those gaps. Then metals and non-metals that has been separated groups are there. Then the periods are there, which shows the metallic character to gradually changing to non-metallic character. Then there are subgroups having the same valency that is also being put there. So this led to the foundation of the modern periodic table. Now, next question is A, B, and C are the elements of Gauguin's triad. If the atomic mass of A is 7 and C is 39, what should be the atomic mass of B? So the average atomic mass of A and B is 7 plus 39 by 2, that's 46 by 2. So the atomic mass of B will be 23. Okay. Next question is lithium, sodium, and potassium were put in one group on the basis of their similar properties. What were those similar properties? All of them are soft metals. They are good reducing agents. They have 1 electron in the outermost cell. They're unipositive ions. They have valency 1. Okay, all these metals impart color to the flame. They are highly unstable. They are highly unstable and react vigorously with air and moisture. They form alkalis, strong alkalis with water. Okay. The next part is the elements calcium, strontium, and barium were put in the one group and form or family on the basis of some of the similar properties. So what were those? They are alkaline, all of them are alkaline earth metals. Okay, the oxides of each of them are alkaline in nature, and each has a valency. Okay, so this is the end of the chapter, the periodic table. Finally, and if you have any doubt, please write in the comment box. All the links will be given in the of this chapter will be given in the description box. If you want to navigate to any of the video, okay, you can go to from the description box also, and the playlist links, all the other playlist links are also there. Excuse me, class 9 as well as others are also there. And if you are interested in the Bengali spiritual channel, then you can also navigate. There is also the link will also be there inside the description box. Okay. So if you have any doubt, please do write in the comment box and do subscribe. You must not subscribe there. And if you are liking the videos, press the like button, share with your friends so that they can also be benefited from these videos. And don't forget to meditate before you start your day. Okay. So thank you. Bye bye.